if we want to simplify this fraction, let's start with seeing if we can factor top and bottom. So let's look at the top. How do we factor that? Well, what I notice right off the bat is there is a GCF. So hopefully you notice there is a GCF of 3. And if I pull out a GCF of 3, that would leave me with 4x squared, because 3 times 4x squared is 12x squared, minus, well, 3 times what is 27? That would be 9. Okay, so I factored a GCF out of this. Now look at this. Oh, that's a difference of squares. I noticed those are squares. It's called a difference of squares. So to factor difference of squares, you want to think, okay, what squared gives you 4x squared? Oh, that's 2x. And what squared gives you 9? Oh, that's 3. So those two pieces, this squared gives you that, this squared gives you that. And this right here is called a difference of squares, and it has a basic factoring look. So when you factor that, leave the 3 out front, it's just going to be each piece, the 2x and the 3, one with a plus, and one with a minus. So you're always going to have, if it's a difference of squares, 1 plus, 1 minus. Don't forget the GCF. Alright, so we have the top. Now let's do the bottom. Let's factor the bottom. Okay, the bottom has no GCF, so I need to multiply the front and back since it has a number in front. So what I'm going to do is I'm going to do a little diamond thing, and I'm going to multiply 2 times negative 12, which is negative 24. I put the negative 5 on the bottom. Again, I multiply front and back, put it top. Middle, I drop the bottom, and I think of 2 numbers that multiply to get this and divide to get that. So if I think about that, oh, I notice it's negative 8 and 3. Okay, then because you have this 2 in front, you have to divide it back off. So divide both of these by that number in front. So you divide both of them by 2. And if reduce, that one doesn't reduce. Actually, don't worry about that. This one does, so this is negative 4. Okay, so what would this look like factored? Well, you take each piece, so you have the x minus 4, and you have the x plus 3 over 2. Alright, and then what I do is I take this and bring it right in front. If there is a denominator left, you bring it right in front. So that would be x minus 4, and the 2 went in front, so that's 2x plus 3. Alright, so this right here is my bottom, and this right here is my top. It's not my answer, that's just the top and bottom of what we are dealing with. So my next step is to put them top and bottom, basically. So we're going to rewrite this, alright, and we have the 3, 2x plus 3, and 2x minus 3, that's on top, and on bottom is the x minus 4 and the 2x plus 3. So we just wrote this on top and this on bottom, and then we look, can anything cancel? Meaning, is there anything the same top and bottom, exactly the same, that we can cross out because it equals 1? And what you should notice is this and this are exactly the same. They cross out, becoming a 1. Nothing else crosses out. So my answer looks like it's going to be the 3. I still got the 2x minus 3 over, I still have an x minus 4. Nothing else can cross out. So this right here is my answer. That is my simplified form by factoring. So we factor top, factor bottom, see if something cancels, usually something will, and there's our simplified version. Now over here, we notice we can't factor the top. Yes, you can factor the bottom, but it's not really factorable, so we're going to try long division on this one. Another way to rewrite rational expressions is by long division. So let's do long division. All right. For long division, here we go. Let me make my fraction bar. I know I'm going to divide by 2x minus 6. This is what I'm dividing by, and this is what I'm dividing. So the numerator is going to go here, and the denominator goes there. Now be careful when you write the numerator out. because I have x cubed, then I have 4x squareds. I'm missing x's, so I need to put a 0x, and then the minus 1. A lot of people forget this. You need a placeholder. Once you start with cubes, you need a placeholder for each variable as you work your way down. Now, what times 2x gives you 2x cubed? Hopefully you realize that that would just be x squared. So x squared times this, x squared times that, we're going to put it right underneath these. So that would be 2x cubed and a negative 6x squared, and we are going to subtract down. What you notice is that cancels. Be careful right here when you subtract down here. Be careful. That's 4 minus negative 6. That is a positive 10x squared. It's so easy to mess that up. Bring down the 0x. My next step is, okay, what times 2x gives you this? Hopefully you notice that's 5x. So I'm going to put a 5x in the x column, and then I multiply 5x times this and 5x times this and put it right underneath here. So 5x times 2x is 10x squared, and 5x times negative 6 is negative 30x. And you should notice that these cancel because you're going to subtract down. You always subtract down. Be careful. 0 minus negative 30 is, be careful, positive 30x. Bring down the negative 1. Okay, almost there, almost there. Okay, so next, what times 2x gives you 30x? Alrighty, be careful. It is 15, positive 15. And so 15 times 2x and 15 times negative 6 goes right down here. Alright, so what we get here is, let's see, 15 times 2x was 30x. And 15 times negative 6, that's a little tough, but hopefully you can see that as 90. And it is a negative 90. And we're subtracting down. So be careful now. That cancels. Negative 1 minus negative 90, very easy to mess up, but it's 89. Got to be careful about that. It's easy to mess up subtracting down, so be very careful. So my final answer is this with the remainder over the divisor. So it looks something like this. My final answer is x squared plus the 5x plus the 15 plus the 89 over the divisor. And that is the answer to it. Again, this is a way to rewrite. You can long divide to rewrite, and there's special uses of long dividing to rewrite a fraction. And there's factor cancel as another way to rewrite. Two different ways to rewrite rational expressions.